Hello and welcome to Geoprocessing with QGIS. In the previous video, we learned how to download free satellite data, both from the web browser through different online portals, and also right from within QGIS using plugins. Now, luckily, most of the images from the popular sensors come already geometrically corrected. But depending on the level of data quality that you are able to access, you may have to do some radiometric corrections or atmospheric corrections. And, just to track back a little bit, we downloaded some Sentinel data. And for the purposes of this video, I downloaded a level 1C product, which is a top of atmosphere reflectance product, which means that it includes information both from the ground and also from the atmosphere. And so the goal here is to take that atmospheric effect from the images to create a more representative reflectance data on the ground. And that's the purpose of this video, just to show you how you can do radiometric corrections on your data. And for that purpose, I want to show you two main approaches using the Sen2 core processor, which is a software developed by the European Space Agency, mainly for processing Sentinel-2 level 1C data into level 2A or bottom of atmosphere reflectance. And the second one, or the other one that I would want to show you, is a more general one, which is the Dark Object Subtraction algorithm implemented within QGIS. And so basically in previous videos, I mainly showed Sen2 core using command line, right? Either you're running Windows or Mac terminal. But for this one, it's not very different, but I would like to show you the same process, but this time embedded within QGIS in a very fantastic and straightforward plugin. And so first of all, let me show you how the data looks like. So the Sentinel data comes in this folder structure. It ends with .safe, and this is how it looks like. So you have data right here in the granules. If you do a few clicks to image data, then you have all the data sets from the different bands right here. This is how it looks like. So let me go ahead and visualize a few of the bands. So the blue, green, red, and the near infrared bands. Drag it and drop into QGIS. Basically, this is an area in the northwest of England, around Liverpool, Southport area. And this is the footprint of the image, right? So first, I will show you the Sen2 core process within QGIS. And to implement that, you need a plugin called the Sen2 core adapter, I believe. Yeah, this one right here. And so you have to highlight it and install it if you haven't already. And when you do, it should appear somewhere under the raster tab or maybe under the plugins tab, but it should appear somewhere here. And it's right here, which is Sen2 core adapter. So you can highlight it or select it to launch it. And what this plugin is basically, it provides a user interface where you can use the Sen2 core processor. And to be able to implement this process, you first of all need to download the software, which is the Sen2 core software. I showed how you can do that in the previous video. I'll provide a link in the description if you want to have a look at that. So basically, you need to download the software, and it comes as a zipped file. So you have to unzip it and then specify the path to the software here. And then the next one is to load in the data. And here you need the folder ending with .save. So this very one right here, you highlight that, select folder, and then the output. So this is a location where you want the results to be returned, right? And if you leave it open, and it's optional anyway, so if you don't specify any location, the resulting level 2A product will be created right at the same location that you have the level 1C product. So I'm going to leave it open, and under the resolution, you can specify which bands you want to process. In this case, I want to process all bands, which includes the 10, 20, and 60 meter spatial resolution bands. And the next big thing is to specify these processing parameters. And these are quite a bit, actually. It's quite a lot of parameters to accurately get correct. And there's already some default values provided here. But to make it simple, there is an XML file in the Cent2 Core software that has information containing all these parameters stored within it. And the name is L2A GIPP, simply means level 2A ground image processing parameters. So I'm going to browse and look for that. The site packages, Cent2 Core, CFG, and it's this one that you're looking for, L2A underscore GIPP.xml. You select that, click open, and you see that the boxes for the predefined parameters here sort of go hidden, right? Because this takes over or what has been entered here. So basically, that's all you need for the process, and you just click on run. Now, this usually takes quite a while. So I'll pause the video and see you when the process is done. Great. So the process has finished. So if we check the location where the data is stored, we should see the level 2A product created here from the Cent2 Core adapter. Let's try to import the same bands, which are the visible and infrared, near infrared bands, and try to make see how it compares. Create a 4-color composite on the fly from each image data. In this case, the level 1C product and the newly created level 2A product. Refresh that. So first of all, I'm going to create a 4-color composite for the level 1C product. That includes the bands that do not end with the spatial resolution. So just going to highlight them. Click on the plus button to add them to the band set. this is the Sentinel-2 data. So once you have them here, you can simply go there, RGB list, done combinations, yes. And this creates a virtual image. So we can see a true color composite right here. Now repeat the same process for the newly created bands. So it looks like the virtual band has been overwritten. So I'm going to save this to a different name or rename the layer. So this will be level 2A. Get rid of these. And now I'll bring in the level 1C bands. Repeat the process. So this will be level 1C. Change the symbology to an infrared or a near infrared for color. And so this is how the data looks like. Okay, let me change that. So you can clearly see that the level 2A, which is the bottom of atmosphere reflectance data, appears less hazy compared to the level 1C product, which shows a bit of atmospheric scattering still persisting over the scene. And so yeah, there you have it. Now the second approach that I want to show you is called the Dark Object Subtraction algorithm. So basically, this is a more general approach that applies to different images from different sensors. So for example, you could apply it to Sentinel, you could apply it to Landsat, and so on. So unlike the Cent2 core adapter or algorithm, which is specifically made for Sentinel data, this is a more general approach. And the idea behind Dark Object Subtraction is that, you know, it's based on the assumption that there will be some surface features that will have no reflectance at all. In that case, there should be zero reflectance data for those surface features. And in that case, if the pixel value for those locations are not zero, we assume that this is the influence of the atmosphere. So basically what the algorithm does is scan through the image to find these minimum reflectance values and then subtract them from all the other pixel values. And this happens for each band. So for each band, the algorithm scans the image, finds a minimum reflectance value and subtract it from all the other pixels. And by so doing, we reduce atmospheric effect. And to demonstrate that, you should have the semi-automatic classification plugin installed. So if you don't have that, you can simply go to plugins, manage and install plugins, and search for semi-automatic classification plugin and install that. And it's actually the same plugin that I just used to visualize the data. And so all you need to do is to launch the plugin. So for that, I will come here to the toolbar, to SCP, go to Preprocessing. And in this case, we want to pre-process Sentinel-2 data, right? So you select that. I think I already have it opened here. And all you need to do is to navigate to the folder that has the level 1C bands and also the metadata file for the image. And to avoid any errors, you would need to make sure that the path towards those files do not have any characters like a dot or a space and so on in the naming of the folders. So for that purpose, I copied the level 1C bands into this folder, which I call DOS1. And I have all the images in this folder just to make sure that the path to the images are pure. So let me go ahead and get rid of this folder. So that there is no interference with the content of the folder. So you want to make sure that only the data from the image bands are within this folder. And I also have the metadata file here, which, by the way, comes with the image download. So this one right here. And so specify the path to those bands. Select that, and then to the metadata file, which is an XML file. And what you want is to check this box right here, which says apply DOS1 atmospheric correction. So you check that. And I do not want to create a band set, so I will uncheck this box. And I'm not going to add the band set, the bands into a new band set. So I uncheck this as well. And basically, that's it. So you realize that once you specify the path to the metadata file, these information boxes get updated. So it shows that the product is a Sentinel-2 MSI level 1C data, the acquisition date, and the platform, which is a bit dark, but you can see it's Sentinel-1B, Sentinel-2B, sorry. And so that's that. You just click on run. And if you do that, the process will ask you to specify the folder location where you want to store the output data. And so I want to keep it right here in the DOS1 folder. So I'll select this folder and the process should begin to run. So this also takes quite a bit of time. So you should see a progress bar shown here. So this should read all the way to 100% and the process will be finished. So I will pause the video again and see you when the process is done. So the DOS1 process is finished and the images are automatically loaded in QGIS right here. So I'm going to repeat the same process and create a force color visualization for these bands so that we can compare the two processes with the original image. So visually, this is how they look like. This is the original level 1C product, which looks obviously hazy, and the output from the DOS 1 correction and the Zen2 core process. So the DOS 1 correction and the Zen2 core process looks very similar. But then if we investigate the pixel values, so you pick this identifier feature here and you click anywhere within the image. So this shows the pixel values for the different bands for the DOS1 output. They are sort of scaled between 0 and 1, but for the Zen2 core process, you realize that they are not scaled. So yeah, that's the main difference that I wanted to point out. So basically, all the data that you see from these different processes are essentially atmospherically corrected reflectance data, except that the original Sentinel data comes scaled to I think between 1 and 10,000. It's part of the product specifications. So if you apply the Zen2 core algorithm, it stays the same. It doesn't change. But DOS1 in the SCP plugin, apart from converting from top of atmosphere to bottom of atmosphere reflectance, it also scales the data. So basically, same information, just different scale. So yeah, there you have it. Thank you for watching. Don't forget to subscribe because there is more coming by way of further image processing. Stay safe, and I will see you in the next video.